Hello, everyone. Mr. Schleicher here with another chemistry lesson. Today we are going to learn about atomic dot structures. So what we're going to be able to do by the end of this lesson is draw atomic dot structures when we have an element, an ion, or an electronic configuration or electron configuration. So if I give you any one of those, then you should be able to draw an atomic dot structure from that. So first things first, what is an atomic dot structure? Well, they were originally developed by an American chemist called Gilbert Lewis in 1902. You might also hear the name Lewis dot structures because they are named after him. And they are actually just a drawing of their elements and electrons, and they can be used to show different chemicals or molecules or chemical bonds. They're really useful for predicting properties of our molecules with all of these chemical bonds. So we're going to use this periodic table in order to answer some questions. This is just one of the ones made from when Texas did the STAR. How do we draw a dot structure? Let's start with just trying to draw with a single neutral atom. So first of all, we want to determine what element that we have and what its element symbol is. Then we want to determine how many valence electrons are in that element. And finally, we want to write the element symbol and surround it with pairs of valence electrons on its four sides. Step number 3, it is just a little bit arbitrary. But we usually use the four sides because that's what all chemists do. And a lot of chemists like to pair up valence electrons as well. So a few examples here, carbon. What I would do first is I would go to the periodic table and then look for carbon. Since I already know where it is, just from practicing so much, carbon's right here, it's number 6, and we can look right here to figure out how many valence electrons there are. So I'm seeing there's 4 valence electrons, and I know the chemical symbol is C for carbon. So what I'm going to do to draw the dot structure is I'm going to write C, and then I'm going to draw 4 valence electrons. So I'm going to pair them up, and maybe I'll put one on the top, one pair on the top, and another pair on just whatever side. So whatever side you're on doesn't really matter as long as they're paired up and they're on either the top, left, right, or bottom. Those are the 4 sides we're looking at. So I have 1, 2, 3, 4 valence electrons. That is the dot structure for carbon. Let's look at nitrogen. Nitrogen's right next to carbon here. Looks like it's in group 5A, so it's going to have 5 valence electrons. And the symbol here is just a big ol' N. So let's go back here, use an N, and let's draw 5 valence electrons around this one. So I'm just trying to draw dots here. Not the most beautiful dots, but dots are dots. So we have 1, 2, 3, 4, 5, and one of them is unpaired here. And we have one side that doesn't have any electrons around it. Let's look for sodium. Sodium on a periodic table is actually Na. It doesn't start with S. So don't get sulfur mixed up with sodium over there. Sodium used to be called natrium in Latin, so that is why it's Na. Here we have 11 electrons, but since we're in group 1A, we only have 1 valence electron here. So we're going to draw the symbol Na with 1 electron around it. See, Na, 1 electron right there. And that's how you draw that dot structure. Let's look at a different situation. What if we have an ion? So recall that an ion is basically a charged particle. So charged means you don't have the same number of protons and neutrons. They're different. And if you have a different number, then you're going to have a different whole number charge. Like it could be positive or negative. So for example, if I have 19 protons and 20 electrons, that means that I have 1 more electron than proton, which gives me a charge of -1 or 1 minus. If I had 5 protons and 3 electrons, now I have 2 more protons than electrons, and that's more positive stuff. So I would have a charge of 2+. So anything that's charged like that is an ion here. So we are going to determine what element that you have to look for that elemental symbol. We're going to look at how many electrons that you have. If you have a positive ion, then you got to assume you have less electrons. The reason why you have to figure out how many electrons you have here is just because you want to draw the correct number of electrons around your element. If you have a negative ion, you're going to add more electrons because electrons are negative, so you have a negative ion, that means you have more electrons. Finally, just draw the structure the same way you did before. So let's look at some examples. We have Br1 minus. Okay, so we got to look at the periodic table to look where bromine is. Right here, it's in group 7A, so it'll have 7 valence electrons, but it has a 1 minus charge. So we're going to draw Br with 7 valence electrons around it. So there's 7, but because there's a 1 minus charge, we add 1 more electron. So I'm going to add 1 more there. And that is almost done. We have to account for this 1 minus charge. So we're going to put 1 minus in the top right. We did not do that the most elegantly. And let's see if I can figure out how to erase this. Okay. 1 minus, somewhere in the top right like that. Normally we'll put the number before the charge. Sometimes instead of putting 1 minus, people will just put like minus instead of putting the 1 there. So just minus is okay because we can assume that if you have just a minus sign, that's 1 minus. Same thing with plus. If you just have like 1 plus, then you could just put plus. Okay, let's look for Ca. Ca on the periodic table is right here, number 20. It should normally have 2 valence electrons since it's in group 2A. So let's look at calcium and the charge here. So Ca normally has 2 valence electrons, but the charge of this ion is 2 plus. So if you have a positive charge, we're taking away electrons, we're going to take away 2 electrons. So these 2 electrons that you just drew, kick them out. They're no longer welcome. And then we have to account for that charge, 2 plus. You definitely have to write the 2 there because this is now, you can't assume that it's 2. You have to write the 2 to tell us that it is. And that is the completed atomic dot structure here. Okay, let's look at the N real quick. N3 minus. N, we're going to look back over here. We did see it before. That was nitrogen. It has 5 valence electrons. But we're going to add 3 to that since it's a 3 minus charge. So N, 1, 2, 3, 4, 5, 6, 7, 8, because 5 plus 3 is 8, and then 3 minus. Okay, moving on to S. S is sulfur. I crossed it out before. It's not sodium. So S should have 6 valence electrons here. But then we're going to add 2 to it because it's a 2 minus charge. So 6 plus 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8 dots around it, all paired up. Then I'm going to do a 2 minus charge in the top right. So that's how we start drawing the the atomic dot structures for ions with the charge in the top right, and then adding and subtracting the correct number of valence electrons. Something else that's really interesting here, that'll be really important later on, is looking at these ions. It seems like we either add valence electrons until they have 8 electrons, or we take away valence electrons until that outer shell is empty. So just something to note for later. Okay, electron configuration. If you have an electron configuration like one of these over here, the first thing you have to do is determine what element that you have. Otherwise, you don't know what element symbol you have to use there. Then, same steps as before, determine how many valence electrons are in that element, and then draw your structure. So assuming that we have a neutral element, let's look, 1s1. You look at our periodic table, 1s1. Let's see, the S block was over here. 1s1 should be hydrogen. And hydrogen has 1 valence electron, so we are going to do H 1 dot. Okay, let's look at this next one. 1s1, Oh, wait, sorry, this is a mistake. It should be 1s2. So 1s2, 2s2, 2p3. So I'm going to skip ahead to wherever the 2p3 is to figure out what element this is. So 2p3, okay, so I know I'm looking around in this p block, and I'm looking in the second row, and I'm going to look for this, let's see, 2p3. I'm going to look for the third element, which is nitrogen. Oh, nitrogen's going up a lot. Okay, so nitrogen has 5 valence electrons, so we are going to draw 5 dots around an N. Wait, I think I drew too many. 1, 2, 3, 4. There we go. Okay, and that is how we draw it from that electron configuration. Finally, you might have some of these like shortcuts right here for these really large elements. These elements have a lot of energy levels. This one, it starts at the noble gas Xe and skips straight to 6s1. So we're just going to skip straight to 6s1 as well and figure out what element that is. The 6, and we're in the S, and the first space in S is CCM, CS. So we're going to say CS since that's in column 1 and has 1 valence electron. So we are going to do a CS and then 1 valence electron around it. And that's it. Y'all are going to have another assignment probably. I might ask questions over drawing Bohr models. So if you ever have to draw a Bohr model, just know that you're going to have some nucleus in the middle, so just whatever dot that you want there. And then, for example, if I'm drawing the Bohr model for carbon, you look where it is on a periodic table. Carbon has 2 energy levels since it's in the second row here, and it has 2 electrons in the first level. You always have 2 electrons in the first level, and it has 1, 2, 3, 4 electrons in the second level, which is also its valence shell. So we would draw like 2 levels with 2 electrons in the first shell and 4 in its outermost shell. And in general, like your second or third or fourth energy level can never hold more than 8 electrons when you're drawing things with the Bohr model. So B-O-H-R. All right. Hope you learned a lot from this video. Please contact me if you have any questions.